Hello everyone. So today we will solve this problem. The question is find out the voltage across the 15 ohm resistance. Okay, that means we need to find out this particular potential or V1. Okay, we can write down this is V15. We need to find out V15. Okay, so here we need to use the KCL. Now we need to identify the nodes. In this node, the potential is 20 volt. In this node, the potential is 0 volt. So this will be also 0 volt. This will be also 0 volt. But we don't know the potential of this one V1 and this one is V2. Okay. That means V15 will be 20 minus V1. Right. So we need to know the value of V1. So if we apply KCL at point 1, then we can write down V minus 20 divided by 15 minus 10 ampere minus 5 ampere plus I. If this is I, then you can write down this is I, right, equal to 0. So this is the problem of the supernode. Why? You can see here there is a voltage source between two nodes, right? That means we can write down V2 minus V1 equal to 10 volt. Okay. So here we have three unknown parameters. Okay. So this is the first equation. Second equation, if we apply KCL at point 2, we can write down V2 minus 0 divided by 40 plus 5 minus I equal to 0. Okay. And the another equation will be V2 minus V1 equal to 10 volt. Okay. So here you can see we have equation 1, equation 2 and equation 3. Right. From equation 1 and equation 2, we can find out the value of I and we can put in either equation. So, if I calculate the I from the equation 2, we can write down I equal to V2 by 40 plus 5, right? And if we put this value in the equation 1, we can write down that V1 minus 20 by 15 minus 10 minus 5 plus V2 by 40 plus 5 equal to 0, right? So this will be equation 4, right? So now we have two equation. One is equation 3 and equation 4, and we have the two variable, right? So we need to solve this one. So equation 3 is V2 minus V1 equal to 10 volt, okay? And the equation 4 is V1 minus 20 by 15 minus 10 minus 5 plus V2 by 40 minus 5 equal to 0, right? So 5 cancel out, right? That means V1 minus 20 by 15 plus V2 by 40 equal to 10, and from equation 3 we can write down V2 equal to 10 plus V1, right? So if we put that value here, then we can write down V1 plus 10 by 40 is equal to 10, right? That means here it will be 120, 8 V1 minus 160 plus 3 V1 plus 30 equal to 10, right? That means 11 V1 minus 130 equal to 1200, right? That means 11 V1 will be equal to 1330. So V1 will be equal to 120.90. Okay, that means V2 will be equal to 130.90. Okay, so we already got the value of V1 and V2, right? That means the V15 will be equal to, if this is plus, this is minus, then 20 minus V1, that means 20 minus V1 is how much? V1 is 120.90, right? So that means it will be equal to around minus 100.9, right? We can write down this will be around 101 volt minus. Okay, why minus? As we assume this is plus, this is minus, right? That's why we get 101 volt. Okay, so we can write down that if this is minus, this is plus, and this is Vx, then we can write down Vx equal to 101 volt. Okay, or if this is plus, this is minus, V15, then we can write down V15 will be equal to minus of 101 volt. Okay, so this is the concept of the supernode. Why we call it supernode? when a voltage source is connected in between two nodes. At that time it will be called a super node. At that time you need to assume a current flow through that two particular node, okay, and that will be I. When we will apply the KCL at point 1 and point 2, at that time you can see there will be a term I. Okay, so what you need to do? You need to take out that I from one equation and put in the other one. Okay, this will be one equation. Another will be, as the voltage source is connected in between two nodes, so that means this voltage minus this voltage will be value of the voltage source, right? So this will be the supernode concept. Or when we will be the expert of the supernode, then how we can write down? At that time, first consider this node and write down the equation, okay? And then consider this node, write down the terms in the same equation, okay? So I just show you how. Suppose I am writing the KCL equation for the supernode. For the point 1, we can write down V1 minus 20 divided by 15 minus 10 ampere minus 5 ampere. Okay, so these three done. Now this branch, right? And this branch is the supernode branch, right? So we don't need to calculate, or we don't need to take this one. Now directly jump to here. So we can write down plus V2 minus 0 by 40 plus 5 equal to 0. So you can see I just apply the KCL in supernode, both the node together, and we get the one equation. And you can see that this equation is exactly same with this one, right? After we analyze the equation 1, equation 2, we get this equation, right? And you can see this equation is exactly same with this equation. Okay, so this is the concept of the supernode. Now let's go to the simulation and just see what will be the simulation result. Here you can see I draw the same circuit, right? And now they told us to calculate the voltage across 15 ohms. I just connect a voltmeter across the 15 ohm. Okay. So let's simulate this circuit and see what is the reading of this voltmeter. So you can see here, this is plus, this is minus, right? So this node they write on plus, this node they write on minus. What we assume in the first V15. So you can see the voltmeter reading is minus 101 volt. The same, exactly same with our theoretical answer, right? And you can see here this voltage V1 is 121 and this voltage is 131. Same as our calculation, right? So this is the concept of the supernode. I think you already understand the concept of the supernode. This is little bit different than the normal concept, and maybe you will get trouble when you will consider this voltage source and these two nodes in the equation. At that time you can think another parameter is coming called I. How to tackle that one? Okay, so I already show you how to tackle that problem. Okay, thank you. Bye bye. Thanks for your time. Please do share this concept with your friends, and if you like this video, please press the like button. It is really means a lot for me. Bye bye.